section modulus. Section modulus, which is denoted by the letter Z. So we know the bending equation, that is M by I is equal to F by Y is equal to E by R, where M is the moment of resistance, I is the moment of inertia, and F is the bending stress, and Y is the distance of fiber from the neutral axis, and E is the Young's modulus, and R is the radius of curvature of the beam. Now in this bending equation, I'll consider these two equations, these two first equations. Here F becomes equal to M by I into Y. We know that the F, the bending stress, will be maximum at the extreme fiber of the beam. Correct? The bending stress will be maximum at the extreme fiber. Correct? So with respect to the extreme fiber, the stresses will be maximum, that is F max is equal to My I into corresponding distance of extreme fiber from the neutral axis. From the neutral axis, let us consider it as Y max. Okay, I will rewrite this Y as Y max. Y max. Okay. Now M becomes equal to I divided by Y max into F max. Okay. Now M is equal to this I by Y max is there, no? This I by Y max itself is called as the section modulus, which is represented by the letter Z into F max. Okay, which means that the section modulus is the ratio of moment of inertia of the section about the neutral axis to the distance of extreme fiber. Okay, distance of extreme fiber from the neutral axis. So this is the definition of the section modulus, which is nothing but I by Y max. Okay, the ratio of moment of inertia of the section about the neutral axis to the distance of extreme fiber from the neutral axis is called as section modulus. Here in this equation you can see that the moment of resistance of the beam will be maximum when the section modulus is maximum. Okay, so this section modulus is one of the parameter which will decide moment of resistance of the beam. Okay, so this is about the section modulus. Now let us see the formula for different sections. Okay, the formula for the section modulus for different geometric sections like rectangle, circle, triangle. Okay, now let us take a rectangular cross section first. Section modulus for rectangle. For rectangle, let me write a figure of a rectangle. Let us take B as width of the beam and D depth of the beam. And let me write the neutral axis. Neutral axis and distance of the extreme fiber from the neutral axis will be, it will be d by 2. That is y max value. Okay, we know that section modulus z is equal to I by y max. I by y max. For rectangle, moment of inertia is equal to bdq by 12. For rectangle, the formula for moment of inertia is bdq by 12, and y max value, distance of extreme fiber from the neutral axis, is d by 2. Substituting in this section modulus equation, so we get bdq by 12 whole divided by d by 2. So d gets cancelled here. We will get the square, and 2 ones are 2 6s are. Finally, we will get the formula of section modulus for the rectangle or rectangular cross section as bd square by 6. Bd square by 6. Okay. Now let us derive the equation for the circle, circular cross section. Section modulus for a circle or circular cross section. Let us take a circular cross section. Let me write the neutral axis. If we assume d as diameter of the circle, okay, the distance of extreme fiber from the neutral axis will be how much? D by 2. Correct? And we know that z is equal to I by y max, and moment of inertia for circle. Okay, the formula of moment of inertia for circle, we know that it is pi d raised to 4 by 64 is the formula. And y max, distance of the extreme fiber from the neutral axis, is d by 2. D by 2. Therefore, the z is equal to pi d raised to 4 by 64 whole divided by d by 2. So here d gets cancelled. We will get cube here. 2 ones are 232. So the final equation is pi d raised to, or pi d cube by 32 is the formula for section modulus for circle or circular cross section. Now in another example, we will take a hollow rectangular section. We will take a hollow rectangular section. Okay. This is the hollow rectangular section. Now let us take the cross-sectional dimensions as capital B. We will take it as outer width of the rectangular section and small b as inner width of the rectangular section. Similarly, capital D as outer depth of the rectangular section and small d as inner depth of the rectangle section. Okay, we know that z is equal to I by y max. Okay, and here the neutral axis will be so this is the neutral axis and distance of extreme fiber. So, okay, this bottom fiber of the beam from the neutral axis is capital D by 2, correct? Capital D by 2, which means y max is equal to capital D by 2. So I is equal to moment of inertia for this hollow rectangle section will be moment of inertia of outer rectangle minus moment of inertia of inner rectangle will give moment of inertia of the shaded portion or the moment of inertia of the hollow rectangular cross section, which is nothing but we know that moment of inertia of the rectangle is BD cube by 12. So capital B capital D cube by 12 minus small b small d cube by 12. Okay, I is equal to 1 by 12 into b into d cube minus b into d cube. Okay, and y max will be equal to capital D by 2. So substituting in this section modulus formula, we get z is equal to I is 1 by 12 into bd cube minus small b small d cube whole divided by d by 2. So here after simplification we will get z is equal to 1 by 6d, right, into bd cube minus bd cube. So this is the formula for section modulus of a hollow rectangular section. Similarly, if we take the hollow circular section, okay, if we take hollow circular section, okay, having outer diameter as capital D and inner diameter as small d. Inner diameter is small d. Okay, let us write the neutral axis and distance of neutral axis from the extreme fiber is again it is capital D by 2. That is y max value. Okay, so z is equal to I by y max and moment of inertia of this hollow circular cross section is moment of inertia of the outer circle minus moment of inertia of the inner circle, which is nothing but pi d raised to 4 by 64 minus pi into small d raised to 4 by 64. If you take pi by 64 common, it will be capital D raised to 4 minus small d raised to 4 I. And y max value is capital D by 2. Substituting in this section modulus formula, z is equal to pi by 64 into d raised to 4 minus d raised to 4 whole divided by d by 2. So here after simplification it will be pi by 32 into d into d raised to 4 minus small d raised to 4. This is the formula for section modulus of a hollow circular section. Okay. Now let us see what will be the section modulus for a rectangle. Okay. Section modulus of a rectangle. Sorry, triangle. Okay. Let us take B as base width of the triangle and H as height of the triangle. Okay. So here we will have the centroid, and let me write the neutral axis. And in this case, the distance of centroid from the base will be h by 3. Okay. And from apex it will be 2h by 3. Correct. Therefore, here the distance of extreme fiber from the neutral axis will be, it will be 2h by 3, not h by 3 here. Okay. The farthest distance of the fiber from the neutral axis. Here the farthest distance or the larger distance of the extreme fiber is 2h by 3. Okay. Therefore, z is equal to I by y max. Moment of inertia of triangle, we know that it is bh cube by 36, and y max in this case is 2h by 3. Therefore, z is equal to bh cube by 36 folded by 2h by 3. Okay. So bh cube by 36 into 3 by 2h. So here we will get h square. So the final equation will be z is equal to bh square divided by 24. So this is the equation for section modulus of a triangle. Okay. Lastly, let us see what will be the unit of a section modulus. Unit. We know that z is equal to I by y max. Correct. Unit of moment of inertia is mm raised to 4 or meter raised to 4 or centimeter raised to 4. And unit of distance of extreme fiber from the neutral axis is mm or meter or centimeter, whatever. So the final unit for the section modulus will be mm cube. Okay. Or we can also mention section modulus by meter cube or centimeter cube. Okay. Distance cube is the unit of section modulus. Okay, which is represented either in terms of millimeter cube or meter cube or centimeter cube. Okay. So in this video, we have understood the meaning of the section modulus, and we have also formulated the equation for section modulus of different sections like rectangle, circular section, hollow rectangle section, hollow circular section, and we have also seen the unit of section modulus. Thank you.